for our section, we are doing area and perimeter. And for the think/warm-up, I have how would you find the area or perimeter of the figure below? And I think we're all pretty comfortable with perimeter, right? Perimeter is just adding up all the sides, right? And now area, it's kind of the same thing, right? I see an area of this rectangle, right? I might want to add that to the area of this triangle. So the idea is I would need to find all the sides here to find the perimeter, and to find the area of the figure, I would probably need to find the area of the two smaller shapes that I know how to get the area of. And this is a quick review of area formulas. I'll run through them pretty quickly. I wouldn't worry about writing them down right now. I posted a PDF of this on Google Classroom for today's work. So triangle is 1/2 base times height. Remember, the height is vertical, right? So the height is like from here all the way down right here. For a square rectangle, it's base times height. Same thing for a parallelogram, base times height, where again, height is the vertical thing. And when I say vertical, I mean like from here straight down, right? That would be the height. Same with the rectangle up here, or the triangle up here. The height would be what's straight down, right? For a trapezoid, the trapezoid is one that we probably don't know, but again, I would just save for writing this down until after, or you can just print out the sheet because it's a PDF if you have a printer, or write it down later. But 1/2 in parentheses, when I see B1, B2, I'm saying the first base and the second base, right? Just kind of those two. And then the height again is vertical, right? So the vertical would be there. This isn't the height, right? This is. Just like this isn't the height here, and this isn't the height here. And then for a circle, this is one that we've probably definitely seen before, but might be a little rusty. We have the area is pi r squared. Remember, pi is just a number, 3.1415, then non forever and ever, some stuff, right? Where r is the radius, which we know what a radius is. It's halfway to the center of a circle. And then circumference is what I added on here. All the rest of this was area because I figured we could do perimeter, right? Perimeter is just adding up all the sides. But for a circle, it's a little different. For the circumference of a circle, so for basically the perimeter of a circle, it's 2 times pi times the radius, or since the radius is just, or the diameter is 2 times the radius, right? Because diameter is one radius and then another radius, you could also just do pi times diameter. So again, a quick review of those, and that should be, we need to make that either in our notes or have it at the ready when we're doing problems like these. And if you don't understand any of the heights or what B1, B2 are or anything, please come talk to me in an open block. And then just a quick reminder of what we've done. The whole idea that we're going to do to solve these is we're going to need to find some sides and be creative. And we've learned 2 methods to help us find at least sides for right triangles, right? And the first one was trig ratios. We used SOHCAHTOA with sine, cosine, and tangent, right? And the other one was the Pythagorean theorem, where a squared plus b squared equals c squared. Now, just a quick reminder, a and b were the legs. It doesn't matter which one's which. So if that's a, that's b. The hypotenuse is always c across from the right angle. And then, if we're looking at an angle x, right? Let's say this is angle x, then opposite would be the side across. Adjacent means next to. Hypotenuse is always the same. And remember, it depends on where this x is. If this x was up here, then the side across would be opposite, right? Then this side would be opposite. And then this side would be next to it or adjacent. And then the hypotenuse stays the same no matter what. And those opposite adjacent hypotenuse are what the OH and A are in SOHCAHTOA. And the rest of SOHCAHTOA, the S was for sine, the C was for cosine, and the T was for tangent. So just a quick reminder of what we've done the past week. Okay, so our first example here is find the area and perimeter of the figure. I am just going to say we probably want just to find some missing sides, right? And let me actually go grab my calculator, which I left over there very fast, because we will probably need it. So if we're looking for the area and perimeter, we're probably just going to be looking for some missing sides, right? And we can label these sides, these missing sides that we want. We could label them anything, right? Maybe this one is H, and maybe this one is X, right? We're probably going to need both of those. Well, so this is a right triangle, right? And to find at least the area, we're going to need the height, right? So we need to find this. But it's a good thing we have a right triangle and two sides, because now I can use the Pythagorean theorem, right? I could say one side squared plus the other leg squared equals that side squared. And then I could solve for h by subtracting over the 3 squared and taking the square root. But I didn't have to. Did I freeze up around? Okay. So I was just saying that we need to find the area and perimeter, we need to find basically the sides we don't know, and we can label them whenever we want. I chose h for height and just x for, some other distance. And so now to find h, luckily we have two sides of a right triangle. So we could use the Pythagorean theorem. If you want to use the Pythagorean theorem, but luckily I also know this is one of my Pythagorean triples, 3, 4, 5. So you could do this, but 3, 4, 5 might be faster. We know that that missing side has to be 4, right? But really you'd get 5 squared is 25 minus 3 squared is 9. 25 minus 9 is 16. The square root of 16 is 4. So either way gets you that h is 4. And I would probably just like to replace h with 4 there. Well, now to find both the area and the perimeter, we're going to need x, or maybe instead of x, I'll even call it b, our base, right? So now to find that, notice we kind of have a larger triangle now, right? We have this big triangle going all the way around like this, which is also a right angle triangle, or a right triangle. So I could use the Pythagorean theorem there. I could say that b squared, this leg, or actually it would be, sorry, we have to be creative here, right? It's this whole triangle, right? So if this is b, then the whole length is b plus 3, right? And then I have to square that. That's this whole leg squared plus 4 squared, right, equals 12 squared. And now it's a little bit of algebra. We have to remember how to do squares. Remember, you don't just stick this square when there's a plus sign, because really what this is b plus 3 times b plus 3 when you square it. right? And so what that's going to get us is b squared plus 6b plus 9, and then 4 squared. So this is this, and then 4 squared is 16, and 12 squared is 144, right? And now this is where some previous knowledge is coming into play, right? So maybe we can combine, we have b squared plus 6b, and then 9 plus 16 is 25. Well, now how do we solve these, right? This is a quadratic. We need to get 0 on one side. Told you this stuff comes back, right? And so now, after I subtract 144, I get b squared plus 6b minus 119 equals 0. And then lucky enough for us, in integrated math, we covered the quadratic formula, and we also reviewed it here. So remember, when you have a quadratic that's equal to 0, you get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And we're not really going to actually have to worry about this minus, right? Because we are not going to have a negative answer. So, and it might be helpful to write our a, b, and c. Remember, those are the coefficients. A, what's in front of our squared term is 1. B, what's in front of our b, or our just single term is 6. And C is negative 119. And so this is why a calculator is going to be helpful. We have negative 6 plus the square root of b squared, 6 squared, minus 4 times a, which is 1, times c, which is negative 119. All over 2 times a, which is just 1. And now this is just something that we are going to throw into our calculator. So then once we throw that into our calculator, we're going to get that x, or I should say b, sorry. It's weird because I made b my base. I'll just call it x. I'll call it x because I made b my base, but in the quadratic formula we use b. And so we get that our side length is about, if I round to the nearest tenth, 8.3. And so we know b is 8.3. And now I found all the sides that I need to find, right? So we could do base times height. So to find the area, the area is 1/2 base times height. And so that's 1/2 times the base we just found was 8.3, and the height we found was 4. right? And again, you could just use a calculator for that. 8.3 times 0.5 times 4. And so the area is going to be 16.6, and then units squared, right? Because an area is always in units squared. And then for a perimeter, we just have to add up all the sides. 8.3512. Right, and so the perimeter is going to be 5 plus 12 is 17, plus 8 is 25, and that 0.3, and then units. All right, so I know that seemed like a lot, but really it's nothing we haven't learned before, right? So when we do stuff like this, we just need to be careful with everything we're doing, right? We know the Pythagorean theorem. We've covered the quadratic formula. If you forgot the quadratic formula, it's fine. It's just a formula you can look up. I'm sure a quick brush up on this stuff made it not too bad. Seems like a lot of work, but it's fine. I only have 3 of those problems in the Go formula for you over the course of 2 days, so I think that's more than doable. What time is it? Let's see. Do we have time for another one? I'll see if I can get to the next one. The next one I don't think is as cumbersome. So the next one here, this is kind of like the one we had in the beginning. We need to find the area and perimeter of the figure. Well, to find the perimeter, I'm going to need to get all of the sides. And to find the area, I'm going to need the area of the triangle and the area of this rectangle. So first things first is I see something super easy, right? If this length is 7, then this length should also be 7, right? And then that's really all the easy stuff I can get off the bat. And now I might want to work on, I don't know, maybe this side of the triangle. Maybe I'll just work on the triangle first, right? Because that's what I know some stuff about. And here I have an angle, so I'm probably going to use some of my trig, right? So I don't know, maybe let's call this x and this y, just to give it a name, right? So if I want to find x, right, I know an angle and I know a side, and I want x. So I want to involve this angle, x and 6. So if I'm at this angle, x is opposite and 6 is adjacent, right? And then this would be the hypotenuse. So opposite over adjacent. And if I'm thinking SOHCAHTOA in my head, which one of those involves opposite and adjacent? Well, that's tangent. So what that means is that the tangent of the angle, 37 degrees, equals opposite, which is x, over adjacent, which is 6. Multiply the 6 over to this side, and I'm just going to write the x on the left side. X equals tangent 6, times the tangent of 37 degrees. And that, again, tangent of 37 degrees, don't let it freak you out. That's just a number. So just do 6 times the tangent of 37 in your calculator. And we should get, if we round to the nearest tenth, the x is 4.5. Okay? So maybe here, I'll now write 4.5. Now we need to find y, right? Y, well, now we could either do more trig, or we could do the Pythagorean theorem. Technically, the trig is going to be more accurate, right? Because the Pythagorean theorem, we're going to involve a rounded number. So I'm going to use more trig, and now I want adjacent and hypotenuse, which is cosine. So Now the cosine of 37 degrees equals adjacent, which is 6 over hypotenuse, which is y. I'd multiply the y over. And then remember, cosine of 6 or cosine of 37 is just a number, so y times some number. To get y by itself, we better just divide by that number, which in this case is cosine of 37 degrees. And so we just do 6 divided by cosine of 37 degrees in our calculator, and we get 7.5. So if we go up here, this is 7.5. And so that means this should have the same length as down here, and that'll be 7.5 as well. And now we have everything we need to do the area and the perimeter, right? So the area, we're going to need to do 7 times 7.5. So the area of this is 52.5. And then we're going to need to do 1/2 or 0.5 times base, which is 4.5, times height, which in this case is 6. It's 6 is the vertical one, that's the height. And we get 13.5. And so both of those areas added together is going to be 66 units squared. And then the perimeter, we just have to add up all the sides. So 7 plus 7.5 plus 7, I'm starting here and going around. Don't include this one here, right? The perimeter is on the outside, so 6 and then 4.5. Right, and then 7 plus 7.5 plus 7 plus 6 plus 4.5 is going to get us 32.